Reusing infrastructure can have complicated logistics, but the rewards and the cost savings can be vast. A Texas bridge owned by the Union Pacific Railroad didn't meet current load rating requirements. The railroad also owned a more modern bridge of similar length in Houma, Louisiana, capable of handling today's heavier loads. Could the railroad recycle the Houma Bridge in a new location? Would it be cost-effective or even feasible? For answers, Union Pacific turned to long-term partner Modjeski and Masters, who designed the original Houma lift bridge.
I wanted them to be a part of the project since they had done all the design and all the footwork for it. So.
It's a movable bridge, which Modjeski and Masters specializes in. The U.S. Coast Guard requires bridges that are not needed to be removed, and so it had to go somewhere.
Repurposing the original Houma Bridge required simultaneous mechanical, electrical, and structural engineering.
This bridge actually sat idle, and during that time period, vandals came in and stripped virtually the entire electrical system out of the bridge for salvaging the copper. Because of that, it required a complete new electrical system.
Challenges with moving a bridge of this size, or any bridge really, is keeping in perspective the entire time what the contractor is going to have to do to both dismantle and get ready for shipping.
The team navigated the bridge nearly 400 miles through an intracoastal waterway from Houma, Louisiana to Freeport, Texas.
Normally the barge would be running 24 hours a day and get here in 3 days. Well, as it turns out, it was a very foggy season, so a 3-day trip turned into about a 6-day trip. But it went well. There were no issues along the way, and the contractor was able to make up that time and get the structure going.
Once the bridge arrived, Modjeski and Masters coordinated the installation despite some challenges.
The most challenging on the part of the contractor, I would say, is getting the old swing span out and then getting the new lift span in, because it requires a lot of coordination and it's time-consuming and difficult.
This is the first time I've ever been experienced with floating in and out of lift span and taking one down, and it's really unique being able to do something you've never done before.
In a 258-foot span, we only have like a 1/4 inch tolerance so that it'll fit. It was very relieving and very satisfying to see that it worked well.
Probably the best part of this project is the fact that it does not interrupt service to these manufacturing facilities. It goes to the port on its regular schedule. We've had zero impact, haven't delayed a train.
To keep trains moving during the bridge's prep and transportation, Modjeski and Masters used an innovative design.
We had to bobtail the swing span, and that required removing the end two panels of the bridge and rebalancing and strengthening members of the swing span so that when it opened and closed, it would clear the tower pier.
The repurposing of the bridge not only kept trains moving and saved the Union Pacific money, it also strengthened the Freeport, Texas community.
I'm hoping that the port will be able to attract more customers due to the fact that we do now have a more reliable and a better railroad bridge.
I just value Modjeski and Masters' ability to make decisions and to solve problems, that arise in the field on a daily basis.
There was a lot of personal gratification on this one, more so than some other projects, because the fact that I did design this system myself 30 years ago, you kind of take ownership.
Not every day do you dismantle a bridge in one state and move it to another state. I think it's a real milestone project for PCL, for Union Pacific, for Modjeski, for everybody, that they can hang their hat on and remember pretty much forever.
In reusing the bridge, Modjeski and Masters solved two problems with one sustainable, cost-saving solution.